Hello friends, today in this video we are going to discuss about the Fischer projection of any molecular structure and the Haworth projection of any molecular structure and how we can draw their structure and how to remember their structure easily. Okay, so this is our main topic of this lecture, and the last thing is how to convert the structure, any molecular structure, from Fischer projection to Haworth projection. Okay, so let's move on to the structure. So for this lesson we have taken the structure of glucose as the model. Okay, so this is the structure of glucose. Here we take for example. So glucose is a 6 carbon molecule, 1 2 3 4 5 and 6. This is a 6 carbon molecule, and where in the first position the CHO group is present, and in the sixth position the CH2OH group is present, and the other carbons where that is the from carbon 2 to carbon 5, there the multiple OH groups are added here in different orientation. In different orientation the OH groups are added here. So how we can draw this structure, and I have to say that this is the Fischer projection of glucose structure. So how we can draw this Fischer projection of glucose structure? So at first we have to draw a basic form of this structure. So the basic structure is 1 2 3 4. So all of this corner we have to take it as a carbon. Okay, so this all are carbon. So here we have to put the first carbon, that is the CHO group of glucose, and this is the last, that is the sixth carbon, that is the CH2OH. And now this OH group and H groups and their orientations, how we can remember it? So we can remember this glucose structure by the plus minus sign. So here this is the plus minus sign, and we have to remember the structure of glucose is plus minus plus plus. So from the carbon 2, so if the OH group is present in the right side, then we will call it as a plus, and if it is present in the left side, then we call it as minus. So here in the carbon 2 it is present in the right side, so that is the OH is right side, so that is it is the plus. So in carbon 3 that is present in the left side, so it is minus, and next in carbon 4 that is OH is present in right side, so it is plus. So in carbon 5 OH is present is again in right side, so it is plus. Okay, so the structure of glucose is plus minus plus plus. So here I wrote it. Okay, so now here how we can put it? So at first in carbon 2 that is the plus, next minus, next plus, and at the end that is plus. So plus minus plus plus. So its structure is plus minus plus plus. Okay, and the other gap we have to fill with hydrogen, that is H, like this. Okay, so this is the structure of glucose in Fischer projection. Okay, so in this way we can draw any kind of structure in Fischer projection by this formula, that is the plus minus plus plus formula. We can draw any type of carbohydrate structure in Fischer projection. Okay, so now move on to the next, that is, so now this the OH group which is bind to this carbon 5, it can attack the carbon 1, and then this O group, that means this oxygen, can bind or can form a covalent bond with this carbon 1, and the C double bond O which is present in anhydride group of CHO group, this double bond is opened, and the hydrogen of carbon OH of carbon 5, this hydrogen come and bind to this OH and form a OH group, and the structure and form a ring structure which is like this. So this is the carbon 5, this is the carbon 5, and this structure bind with the carbon 1 and form a ring structure and produce one OH group and one H group. OH is because this aldehyde group break the double bond and hydrogen is bind from the carbon 5 OH of the carbon 5. So this produce a OH group here and a H group. Okay, so this is the structure, ring structure of glucose. So why we should know this structure? Because to convert the Fischer projection glucose structure to Haworth projection, we have to know this structure. We have to know how it's generated. Okay, so now we will see this ring structure of glucose, and depending on this OH and H, the orientation of this glucose now can be two types. So that means one type of conformation will be OH will be in right side and H will be in left side, or like this. Okay, and in other structure OH can be present in left side and H can be present in right side. So we can get two structure of glucose like this. So here OH is present in right side and this is the carbon 1, and here OH is present in the left side. Okay, so this structure is known as alpha D glucose and this structure is known as beta D glucose. So how we remember that this structure is alpha glucose and this structure is beta glucose? So we have to remember that alpha means after. So we have to remember that alpha means after and beta means before. So how we can remember this? So before means it's come before this structure, so it is present in left side, so that is before, so that's why it is beta structure, and it come after, so that is present in right side, so it is known as alpha. Okay, so alpha means after, it's come after, and beta means before, it's come before. Okay, or in other way in Hindi we can understand it as beta means बाएं तरफ, B for beta, B for बाएं तरफ. ठीक है, ऐसे हम याद रख सकते हैं. ठीक है. Okay, so move on to the next. So from this structure we can convert it to Haworth form of glucose structure. So this is the alpha D glucose of in Haworth projection, and this is the beta form of glucose in Haworth projection, and this is the pyranose structure or pentagon structure. Okay, so how we can transform this structure from Fischer projection to this Haworth projection, that we will discuss in our next slide. Okay, so here this is our Fischer projection structure, where this one is the anomeric carbon, that means it can be alpha structure or it can be beta structure. Here it is present in the right side, so it's come after, that's why it is alpha structure. This one is alpha structure, and if this OH is present in before, that means left, then it will be beta structure. Okay, so this one is the alpha structure. So if we convert it into the Haworth projection, then this one will be always the carbon 1. Here this one is the carbon 1 and this one is carbon 1. So here the OH is present in right side, and right side, where when the OH group will be present in right side, and in Haworth projection that OH will come in downside. Okay, so and if the OH is present in the left side, then in the third, here you can see third, then it will present in the upper side. So how we can remember this structure? So we have to remember this. So to draw this at first, so this is our structure we get from Fischer projection, and now we have to draw this structure, this pentagon structure or pyranose form of structure. So how we can draw this? So we can draw this by two way. First one is like this. At first we have to draw this oxygen or O group, and then we have to draw this like that, and then in each corner we have to produce one straight line from that, and we have to consider each of this corner as one carbon. Okay, and here in the this one is the first carbon, this was the second, this one is the third, this one is the fourth, this one is the fifth, and here the sixth carbon, that is the CH2OH, will be present always in the upper side. Okay, so now how we can place these OH groups, OH and H group in Haworth projection. So for this we have to consider ourselves or any kind of man who place his both hand like this horizontal position, and his head will be towards the carbon 1, head will be present towards the carbon 1. So his right hand is this and his left hand is this. So in structure this is the right side, this is the left side. So this OH group present in the right side of his hand and this is present is left side of his hand. So structure of the in Fischer projection, OH is same as the person standing here like this. Okay, so now we have to take this man to this structure like this, where this man move towards the carbon 1, so his head will be towards the carbon 1. Okay, and in that position his right hand will be this and left hand will be this. So now this OH group is present in right, so we have to put this OH to the right. Right means downside, so where in carbon 1 we have to put this OH in the downside, that means this position. Okay, so next we know that from carbon 2 the sign of glucose is plus minus plus plus. So plus means in right side and right means downside, so OH will be in downwards. And next in third carbon, that is minus means left side, so OH will be present in the left side, left mean upper side, so here the OH will be upper side. And next in the fourth carbon, that is plus minus plus, so plus means right side, right means downwards, that means it is here like this. And in the sixth carbon always CH2OH will be in the upper side. So now we have to fill the gap with the hydrogen in H. Here we have to fill with hydrogen. Okay, so in this way we can create or generate the structure of glucose or any kind of structure of carbohydrate from this Fischer projection to this Haworth projection. So the main gist of this structure, we will recall this, that is this one is our first Fischer projection ring structure of glucose, and now we have to first draw a pentagon structure and then we have to add this oxygen here like this, and this will be our carbon 1, 2, 3, 4 and 5. And in next we have to add in this all carbon in all corner, we have to draw a straight line. Okay, and we have to put this CH2OH group at the upper side, and now we have to add these OH groups as per the this man standing towards the carbon 1, and this will be his right hand, this will be his left hand. So as per his hand saying the direction of the OH. Okay, so this one is the alpha structure. Why? Because this is the after means alpha, so this is present in right side, so this is the alpha structure of glucose, so OH will be present in the right side, right means downwards, so here OH is present like this. Then we remember the structure of glucose, that is plus minus plus plus, plus means right, right means downwards like this, and plus minus, minus means left, left means upside, and here plus minus plus, plus means right, right means downwards. Okay, and now we have to fill all with hydrogen like this. Okay, so in this way we will get this structure of glucose. Okay, so in this way any kind of structure of any kind of structure of carbohydrate we can draw, or we can convert it from Fischer projection to Haworth projection. Even we can convert the Haworth projection structure of glucose without getting the Fischer projection structure. How we can say? So at first we have to draw the O or oxygen, then we have to draw this pentagon structure like this, then in each corner we have to draw this straight line structure, and then suppose we have said to draw the beta structure of glucose. So beta means left or बाएं तरफ. So left means here left is upper side. Left is upper side. So we have to put our OH into the upper side, upwards. Okay, and in next from carbon 2, that is plus minus plus plus. Plus means right, right means downwards. So here OH is here, plus minus plus, and here plus means CH2OH, and we have to fill it with hydrogen. Okay, so this is the beta structure of glucose. Okay, so in this way we can draw any kind of structure of carbohydrate in Fischer projection or in Haworth projection, or we can convert it from Fischer projection to Haworth projection. Okay, so thank you for watching this video.